Hello everyone. So today we are going to see trim a binary search tree. We are given an input of a tree root and two integer values low and high. So we have to trim the tree with values only between low and high. If any value goes lesser than low or greater than high, we have to trim it. So consider the example 1. If you see there are 3 nodes and the value of low is 1 and high is 2. So they trim the value 0 as this is less than low. Next, moving on to our next example, here the high and low are 1 and 3. So now whichever value is less than low, that is 0, and greater than high, which is 4, are removed and only the rest of the tree is being returned. So now how are we going to approach? In this video, we are going to discuss two different approaches for the same problem, trim a binary search tree. So the first approach we are going to see is iterative approach, and the second one is of course recursive or recursion. So now going for our iterative approach, we are going to use a simple VST to traverse all the nodes in a tree and then check if that node is less than low or greater than high, then take it off and assign a new left or right child. So let's see how we are going to do it. So now for iterative method, we are going to have a stack. So what does the stack hold? The stack is going to hold list of tree nodes. That is, the list is going to have the current node and the parent of that node, parent or head of that node, we could say. So now I'm initiating my stack to current node that is pointing at a root node and the dummy head which is going to update to every other node as it gets traversed. Now once a node is inserted into stack, I'm going to pop that node from stack. And now let's go for a dry run with this example given. Now our first root node is 3 and the stack is going to have 3 and a dummy head. Now 3 is inserted and its dummy head is inserted into stack. Now moving on to its left child. So we are checking if our left child satisfies the condition, that is greater than low and less than high. No, it is less than low. So in this case, we are just simply going to assign the left child of the root to null. So this left child is going to become null, and the right child we are checking, we are coming to right child. So if you check, the right child also is less than high, which means this is again not satisfying the criteria. So we are simply putting the right child of 3 to null. So moving on to left child of 0 and right child of 0, it doesn't have any left or right child. So coming back to 4, 4 has a left child and no right child. So let's traverse the node 2. In this case, 2 satisfies the condition. So what are we going to do? We are simply going to put 2 into our stack and the head is going to be previous node which is in stack. So now let's traverse left child of 2 and right child of 2. There is no left child of 2. So moving on to the right child, that is 1, that is our final node, and checking whether 1 satisfies the condition or not. Yes, it is satisfying the condition. So we are going to push that 1 to our stack. And its head or parent is going to be the previous node in stack. So finally, let's check whether 1 has any children. No, 1 doesn't have left or right node, so the stack empties. The root of the head node is going to be returned as the root of our new binary trimmed tree. So the tree now looks like 3 that has a dummy head, that is what we are going to return as root, and then 2, and finally 1. So this is how our iterative approach works. So this works in order of n time in worst case. So moving on to our recursive approach. So let's get started with our recursive approach. Our recursive approach is going to have a method to get itself recursed. So the method will be passing the parameters of root node and low value and high value, and it will return a tree node again. So now starting with our root node, we are going to send 3, the root node value, and 1 the low value and 3 high value. So now this method is going to call two other methods, that is its left child 0, 1, 3 and its right child 4, 1, 3. Again from 4 we are going to traverse its left child and right child. So in this case from 4 it is going to call 2, 1, 3 and there is no right child. Again from 2, 1, 3 it is traversing whether any left child are there. No, it doesn't have any left child. So moving on to its right child, it is going to call there is no left child and right child is going to call 1, 1, 3. So if you see the values first, it has called 0, 1, 3. It checks whether 0 is within the range 1, 3. No. So it is going to return null value. So again moving on to this, it is checking whether 4 is within the range 1, 3. No. It is also going to return null value. So moving on to this, it doesn't have any child. So moving on to this, 1, 1, 3, yes, it satisfies the condition. So it is going to return a tree node 1. It returns the node 1 to this method. So what this method will do, it will check whether 2 is within range. Yes, 2 is within range. So it is going to return 1 and 2. So finally moving on to this method, it has called all these methods. So now it checks whether 3 is within range. Yes, 3 is within range. It is going to return 1, 2 and 3 and that is our output. So here we have the code for a recursive method where it just checks root dot value is greater than high. If it is greater than high, it simply return to root dot left. Since it is a binary tree, if the value is high, it must be having lesser value in left side. And again, if the value is low, it must be having higher value in right side. So root dot left is equal to root dot left low comma high and right is equal to trim bst of root dot right comma low comma high. So this recursive method will get us our output. Let's run. You can find both the iterative and recursive code in the link in description. So yes. Thanks for watching. Thank you.